In this lesson, we will review the basics about multiplying and dividing fractions. Let's take a look at some examples. The main thing to remember about multiplying two fractions is that you will be multiplying the numerators and then multiplying the denominators, and your answer then will be left as a single fraction, and then you can of course convert it into a decimal if there need be. So there is no need to find common denominators. So it's relatively easy as far as fractions go, right? It's one of the easiest operations that you have. So for example, 2/3 times 3/5. So let's multiply the tops, the numerators. We get 6. Multiply the bottoms, or the denominators. We get 15. And we can simplify this a little bit. So 3 goes into the top and the bottom. 3 goes into the top 2 times and into the bottom 5 times. So we can reduce the fraction and leave our answer as 2/5. Of course, you could also leave it as a decimal form as 0.4. Or maybe a bit more accurately, I should write it 0.4 to be less confusing. 0.4. Now, could we have done it a bit differently with perhaps saving some time without having to multiply things together? Well, we can reduce the fractions before we multiply. Again, the thing to remember is when you're multiplying two fractions, everything on the top is being multiplied and everything on the bottom is being multiplied. And if you write it as a single fraction as such, now anything from the top can be canceled with anything from the bottom because you have multiplication all throughout the top and multiplication all throughout the bottom. In this case, the 3's cancel, and there we have the same answer, 2/5. Now that approach will be especially helpful in this next example where the numbers are larger. You know, who wants to multiply 15 times 24 when you can first reduce your fractions and then multiply? You know, it would be a lot easier. Of course, with a calculator, perhaps it doesn't take that much longer to do it, but sometimes your professors may ask you to do it by hand without even using a calculator. In that case, simplifying it first saves a lot of time. So let's begin. We have 15 over 35. Let's simplify that before we multiply. 5 goes into 15 3 times, and 5 goes into 35 7 times. Okay. Then over here we have 24 over 16, and we can also reduce that one, and 4 goes into both of these. As a matter of fact, 8 goes into both of them, so let's do it. 8 goes into 16 2 times, and 8 goes into 24 3 times. So then we can write the entire fraction as, the product as 3 times 3 is what we have in the numerator, over 7 times 2 is what we have left in the denominator. So simplifying that, we will get 9 over 14. And if you were to do it the other way, if you just multiply through in the beginning, 15 times 24 divided by 35 times 16, you would have obtained 360 over 560. And once again, you could have simplified that. First divide both sides by 10, and then divide both sides by 4, the top and the bottom, and you would have obtained the same exact answer as we got over here. This one just saves some time because we got rid of the larger numbers early on, and the multiplication was simpler in the next step. Now, what if you have a product of 3 fractions? Same idea. Whatever the method that applies with 2 fractions, it will apply with any finite number of fractions. And the idea is, if you're multiplying fractions, multiply all the numerators, 2 times 5 times 8, and multiply all the denominators, 3 times 7 times 4. If there are any simplifications we can do along the way, let's do that. Instead of multiplying the tops and the bottoms and then dividing, this will save time. So I will let's see, 4 goes into 4 one time, 4 goes into 8 twice. And it looks like that's the only simplification we can do here. And our answer will be 2 times 2 times 5 divided by 3 times 7. So here we have 4 times 5 or 20 over 21.